Next, see how World War II technology...
An alien nation. Marine biologist Alex Kerstich studies the underwater world of the Sea of Cortez. This Mexican coast is rich in wildlife. Alex Kerstich has been diving and filming here for 20 years. One summer's night in August 1991, he went out with an underwater camera to look for squid.
I went to the water and I could see between 10 and 12 of the Humboldt squid. As I was taking a few pictures, I noticed that I was heavy and I was starting to sink. One of the squids had a hold of my flipper and it was pulling me down. All of a sudden, down about 30 feet, I felt a slap on the back of my neck. I could feel the suckers and the teeth digging into my neck. But the thing that concerned me the most was the beak. Had it bitten me on a jugular vein, there was a very good chance that I could have bled to death.
The animals that attacked him were Humboldt squid, aggressive and intelligent carnivores, with a maximum size of 12 feet and a beak that can cut through the oars of a boat. Babies, compared to Architeuthis ducks, the fabulous giant squid of the deep ocean. Seafaring men throughout history have reported terrifying encounters with the monstrous devilfish of legend. But the giant squid is no myth. This female Architeuthis washed up dead on a beach in New Zealand in December 1995. She was 26 feet long to the ends of her deadly whip-like tentacles. Squid reaching reported lengths of up to 55 feet, stranded on beaches all over the world, but particularly in Newfoundland and the North Atlantic coast. And always, the giants are dead. Frustratingly for scientists like Dr. Clyde Roper of the Smithsonian Institution, no live specimen has ever been seen, let alone captured.
For hundreds of years, giant squids have been washing ashore on beaches like this. But we don't know exactly where they live. We don't know their habitat and behavior. The only thing we know about giant squid is from looking at the stranded carcasses so that we can know something about their form. We really have just begun to scratch the surface of our knowledge about giant squid. That comes from studying the few animals that have washed ashore on beaches like this. We don't know if these animals are the slow, the sick, and the stupid, or even the smallest ones. But we do know there must be millions of these animals that live offshore in the depths of the sea. If we are ever going to learn about their biology and their behavior and their habitat, we're going to have to move from the edge of our world into the depths of their world.
It's a world humans enter at their peril. Even on the brink of the 21st century, the oceans are an alien universe. Water covers 2/3 of the surface of our planet. And for marine biologists, the secrets of the seas are as challenging to science as the mysteries of outer space. Off Cape Cod, Massachusetts, scientists from the Woods Hole Marine Biological Laboratory set out in search of one of the 47,000 known species of mollusk. One member of a huge phylum of animals, from snails to octopus, whose lineage goes back 500 million years. They hope to catch a small species called Loligopeali, tiny cousins of the giant squid, numerous in these waters. Dr. Clyde Roper joins the trip. It's a chance for him to learn more about living squid behavior, to cast light on the mysterious biology of the elusive giant squid. Squids, like octopus, are mollusks from the class called cephalopods, which means heads with feet. Inside these heads are the largest brains of any of the soft-bodied animals of the world. These small invertebrates are a triumph of evolution. Scientists have identified 700 species of squid living today. Some squids hunt in packs. Some are solitary. Some live in the tropics. Some at the poles. The smallest measures less than half an inch. The largest, no one yet knows. An old New England fishing boat, named after the species of squid the scientists have been to sea to find. They've landed a good catch today. Especially in the summer months, the research demand for squid here in Massachusetts is enormous.
7, coming back.
The boat provides squid for up to 60 scientists who come from all over the world to work at the Woods Hole Marine Biological Laboratory. Squids are valuable in medical research because they have unusually large nerve axons, 10 times the diameter of human axons, which means they can teach neuroscientists a great deal. But there's also a team of marine biologists here, interested specifically in the physiology and behavior of the squid. The Director of Marine Resources is Dr. Roger Hanlon.
Squids are voracious carnivores. These are predators that actively pursue prey, and so they've evolved adaptations to be very excellent at doing so. For example, they have arms and tentacles and eyes and the brain and the musculature to chase prey of a wide size range, detect them, and get them very efficiently. So the process goes something like this. When the two eyes come around and they spot the prey, the eyes wrench forward for binocular vision so they get the exact right distance for the tentacular strike. Then all of a sudden, these two tentacles reach out at blinding lightning speed. Boom! And they've got the prey with the suckers. They draw it rapidly back. Then the 8 arms, acting as a very large mouth, grasp this prey organism and hold them very securely until the very large beak starts chewing away and they eat the prey.
Prey stands little chance against this formidable armory. 2 long tentacles, kept rolled up inside the body until needed. 8 greedy arms, studded with suckers. In some species, the suckers have teeth of their own. Concealed amid the flailing arms, the hidden weapon, a grinding, hard, bird-like beak. The equipment is exactly the same in its huge cousin, the giant squid. Prey reduced to pulp. In seconds. These were the weapons turned against Alex Kerstich, the marine biologist attacked by squid off the Mexican coast in 1991. The attack almost cost him his life. The attacker is common in the waters of the Sea of Cortez. It's unusually vicious and aggressive even for a squid. Though it travels in huge shoals, it hunts alone. Dosidicus gigas, or Humboldt squid.
All of a sudden, down about 30 feet, I felt a slap on the back of my neck. It was a second squid that had wrapped itself around my neck, and the suckers of the squid have teeth And I could feel the teeth digging into my neck. And I felt rather uncomfortable, but the thing that was really worrying me is the beak. They have a very large, powerful beak, just like a parrot's beak. We did see one squid attack a thresher shark while I was underwater. The humble squid came in, grabbed the shark by the head, and took a chunk the size of an orange from the side of the head of the shark. And so this is what got me a little bit concerned.
In the frenzy of his fight to free himself, Kirstich noticed something else. His attackers were changing color before his eyes. A show of color and light, the uniquely spectacular and beautiful communication system of the squid. Human observers can never be sure of the meaning of these communications. But in black and white, it's easy to see their beauty. And scientists do at least know how the colors are produced, by special skin cells called chromatophores.
Well, squids are the masters of color change. They have control of the brain of the skin. And in the skin, you have chromatophores, tens of thousands of these chromatophores in the skin. And there are individual nerve fibers coming directly from the brain that tell those chromatophores to open or to close this pigment of color. And when they do that very precisely, you get patterns in the skin. These patterns in the skin are used for the different behavioral strategies. And those strategies can be to communicate with one another or to be camouflage. And there's a wide range of these, imparting a speed and diversity that very few animals have. And it's this elaborate brain with all these nerve fibers telling the skin what to do in a very coordinated fashion that allows this. And collectively, you have a very special system indeed.
Chromatophores in the skin allow color change in almost all squid species, including the giant squid. Some species have photophores too, cells that can light up. Bioluminescence, bringing light and beauty to the dimness of the undersea world, as the squid travel long distances in search of prey. These are animals built for speed and agility. Their unusual method of locomotion, jet propulsion.
They've often been referred to as the jet-powered torpedoes of the deep. And jet propulsion really is their main means of movement. However, they can fine-tune their movements with the very large and delicate fins that allow the yaw and pitch movement so important in positioning. But then they squeeze the water out of that body cavity at very high pressures to allow them to jet forward or backward with blinding speed to capture prey, or in some cases, and very importantly, to evade predators.
Jet propulsion works equally well in both forward and reverse gears, giving mobility, speed, and maneuverability to all species.
Well, certainly the jet propulsion system in this squid is very similar in the giant squid. But the giant squid undoubtedly has one other capability that's very different and unique compared to this squid, and that is the ability to hover motionless in mid-water. So imagine, if you will, this large, dark submarine lurking in the depths, waiting for prey to come nearby, then using all these other sophisticated, fast tools to grab them. So what you can envision then is an area of extreme danger for any prey that wanders nearby.
As it hovers motionless in the water, the giant squid can move off at high speed using its jet propulsion system. It's a system of underwater locomotion far more effective than anything human submarine engineers have yet invented. A submarine which could move silently about the ocean by sucking water in and expelling it like a squid would be a huge advance in military technology. For submarines and giant squid, both need stealth in defense and surprise in attack. The Woods Hole fishing team leave for another long night squid hunting. Scientists know there are limits to how much more they can learn, until they catch a living giant squid. Sometimes, in the stomachs of sperm whales, scientists find the undigested remains of the beaks of giant squid. Sometimes on the bodies of the whales, they find sucker marks the size of hubcaps. Somewhere in these dark seas lurks the answer to their questions. Architeuthis ducks, the Latin name which means leader of ancient squid. What does it eat? How does it breed? How big can it really grow? In the Mexican villages which line the Sea of Cortez, fishing for squid is a matter of survival, not science. For half a century, Ubaldo Benitez has been earning his living this way.
I'm an old fisherman. I have been fishing the sea for 50 years. I was very young when I started. There are so many squid here. There are lots of squid. The squid can be very big, between 25 and 35 pounds. They are fierce and dangerous. If a fisherman fell into the water, he'd be devoured. I wouldn't go into the water. They would eat me. Just washing your hands in the water can be dangerous.
The traditional method relies on a simple hook and line. If the squid are big, the safety of the lone fisherman cannot be guaranteed. But the squid are plentiful and greedy.
Fishing for squid is very easy because the squid rise up to the light. They rise up gradually to the surface until they're within reach. And then you can haul them in. That's how you get a good catch. Often the squid are found in deeper waters, 20, 30, 40 fathoms down. At depths like this, it is harder to fish because the squid are very strong.
That the biggest squid live far below the surface of the ocean, in the inky depths of the cold sea, is the opinion of a majority of scientists. So what is it that brings the giant squid onto the beaches of the North Atlantic to die? Dr. Clyde Roper of the Smithsonian Institution offers an intriguing theory.
There must be thousands or even millions of these magnificent animals down in the edge of the deep sea. So part of the mystery is, how do these animals get from their natural habitat, or what we believe is their natural habitat in the deep sea, to the beaches?
The answer may lie in one more extraordinary aspect of their physiology. Squid blood is thinner than human blood, and its color is blue. Especially in warm water, it's less efficient than our red blood at carrying oxygen. Is this the secret weakness of the giant squid from New Zealand? Did oxygen hunger bring her gasping to the surface and strand her to die? A careful study of the worldwide pattern of ocean currents offers a clue. At the Woods Hole Oceanographic Institute, scientists use computers to track the movement of the oceans and the temperature variations in the North Atlantic swells. By studying these patterns, Dr. Clyde Roper has formed a hypothesis about how the giant squids die.
We're looking at a map of sea surface temperatures of the North Atlantic Ocean. Essentially the red and yellow and orange are warm water, and the green and especially the blue are cold water. We know that giant squid cannot live in waters above 10 degrees because their blood will not carry oxygen in warm temperatures. So that means they are restricted to temperatures below 10 degrees. It is possible that these animals are living along this area where between the boundary zone of the very cold water and the warmer water. We know that the Gulf Stream undergoes meanders and shifts. It's possible that warm water is brought into their habitat and they die and then float to the surface because they have lightweight ions that make them float, and then somehow get incorporated into the local or regional circulation and then drift ashore. But until we actually make observations on living specimens and find out exactly where they live and the conditions under which they live, we can only speculate.
The frustration of the human scientist faced with the mysteries of an alien world. We know the giant squid exists. We've seen it's dead. But no biologist has ever seen one alive. Dr. Roper lives in hope that one day he will encounter the giant squid and learn from that meeting the secrets of the biggest and fiercest invertebrate animal in the world. But Alex Kirstich, marine biologist and underwater cameraman, still dives in the Sea of Cortez. As a scientist, he shares the desire to know more. But as a survivor of squid attack, he knows that in the water, he's just a vulnerable prey animal. In the cold, dark ocean, Architeuthis dux fights with whales and wins. Against a frail human opponent, victory goes to the leader of ancient squid.
Coming up, discover which animals really have a toxic defense on fangs. Then witness nature's deadly wrath, the destruction of a tidal wave on raging planet. All coming up, only on the Discovery Channel. Explore your world.